Hey guys, welcome back to AlgoYogi. We are doing tree series right now. Let's move on to our next problem, which is kth smallest element in BST. All right, let's go to the problem, which is on LeetCode. It's marked medium. Now, given the root of a binary search tree and an integer k, return the kth smallest value, that is like 1th index, basically, 0th indexed value will be basically kth smallest value. So now, of all the values of the nodes in the trees. Now, that's just simple to understand. You guys already know. So if I have a BST is binary search tree. Basically, if we are searching for a value, we can do it in log of n times, because we can prune the values going if we need to go to the left subtree or the right subtree. Now here it is asking us to return the kth smallest value. So k will be given, our tree is given, root reference is given. It's just we have to find out the kth smallest value. Now how are we going to do it? So if you already know that binary search tree has a property that if we are doing an in-order traversal on BST, then it will return a sorted nodes array. It should return a sorted nodes array. How? Why? Let's see. Because in-order traversal is basically you process left subtree or left child first, and then you process root child, and then you process right child or right subtree. And since it's a BST, and BST has the property that root will be greater than 1, left subtree, and root will be lesser than my right subtree. So now you tell me, if I am visiting all the nodes in this order, this particular order, and I know this has to be smaller than my root and this has to be greater than my root, then, sorry, not greater, smaller than my root, and right has to be greater than my root, then if I have a simple tree, which is, let's say, 3, and then it's 1, and then it's 4, if I'm visiting basically the left child first, if I'm doing the in-order traversal on this particular tree, then I'm going to have 1 first, because I'll visit left, right, and root. So I'll visit 1 first, then I'll visit 3, and then I'll visit 4. Tell me, isn't it sorted? Isn't it a sorted array? It is. So that's the property that we're going to use. So we're going to iterate this particular tree using in-order traversal, and it will return us a sorted array. Then we can just return the kth minus 1 indexed element. So that would be the smallest element that we are actually looking for. Kth smallest element, not just smallest element. So let's iterate over this tree using in-order traversal. That is, go to the left, process the left, it's left, there is nothing over here, then come back, process the root, which is 1, then process the right, which is 2, go back, process the root, which is 3, and then come back to the right side, process the right side, which is like it doesn't have anything on the left, and process the root, which is 4. This is my in-order traversal array. Now it's asking for the kth element. K is like, what is the kth smallest element in this? At particular first smallest element is 1, which is at the 0th index. Okay, so we'll return 1. Simple, really easy problem and easy to implement. Let's implement the solution right here. Okay. So simple, we are going to basically have, let's say, in order array that is just or let's call it in order node, that is this, and let's create in order function in order that will take the root, and if not root, then it's just simply return, and we're not returning anything from here, we just want to store the values in order nodes, and we're going to do it right here. So in order, what happens is we process our left subtree first, or left child first, and then we're gonna append the values to my in order nodes dot append my root dot value. It's not gonna process the none values because it's already returning this check. Now let's just process the right subtree dot right. All right, then let's just call this in order function on root, and what else? We are simply just returning the kth value, the kth smallest value from our in order nodes values basically, and that would be at index k minus 1 because it's 1th index, and we need to return index minus 1 because first element will be at the 0th index. All right, let's try to, let me zoom out and run it on our examples. All right, runs fine, and submit it, and it's a recursive solution. All right, let's write down the time complexity. Time complexity is going to be big of n is the number of nodes we are visiting, and space complexity would be big of h, which is the height of the tree. So we can also do a minor improvement in this problem, and that is since we are only looking for kth smallest element and we are processing from left to right subtree, and we will find basically kth smallest element after searching kth element basically. So k elements because we will be processing until the root, and then we start putting the values in my in order nodes. So what if I basically check if the length of this in order is already equal to k, then means I also want to return here. I don't want to go back, go to further right nodes, like right node, root node, or whatsoever. If I'm done, let's say if I was only looking for first k, like if my k value is just 1, then and I'm processing in order traversal, then it will come down here to 1. It will, as soon as it's done processing 1 and it checks this is already equal to 1, then it will just return, rather than processing 2 and then 3 and 4. It will just keep returning all the values. It wouldn't keep checking, so it will just do a return from all the nodes that are already put onto the stack to process. So this is an improvement. If we submit this one, then I think there will be some improvement in our time complexity. It's kind of not. Let me try again, because sometimes doesn't matter. All right, but this, you see the improvement right here. Okay, so but this time our time complexity would be basically worst case we will be processing everything. So let's just keep it n, or we can keep it k, whatever you guys want to do it. But then let's mark it solved, and see you guys in the next problem. Bye bye.